Hi guys, welcome to chemistry lesson 7.04 part 2. So I decided to make this a part 1, part 2. So what we're doing is 704, everything in 704 is a type 1 cation. And remember we said a type 1 cation is an cation, which is also a metal. They come first, cations do. And type 1 means it has only one possible charge. One possible charge. So we're going to put all of the type 1 cation compounds together. Now, in the last video, we talked about having a binary compound, which meant you just had two types of elements. Ternary, the definition for ternary, means you have more than two elements. More than two elements. And the cases where you have something that's ternary, you have a polyatomic anion. Polyatomic anion. And just to review, polyatomic anion is a covalently bonded molecule with charge. And you've been memorizing these. So you should know by now that SO4 is sulfate and PO4 is phosphate and SO3 is sulfite. So these guys have unique names. So the other thing we know about polyatomics is they have a unique name and you kind of have to memorize them. So for example, if I have, this is just kind of an aside, excuse me, but if I have a PO4 and there's no charge, this is a nonmetal and this is a nonmetal, and this would be a phosphate, phosphorus, I had a brain blip there, tetraoxide. But if you throw 3 electrons on there and you get PO4 minus 3, now you have phosphate. This is a polyatomic ion because there's a charge. Ions have to have a charge. This is a, oh my gosh, all of a sudden my words are just gone today. This is my first recording after being back from Christmas. So this is a covalent compound. So we have to use our prefixes. All right. So what happens, what's different if we have a polyatomic anion instead of just a monoatomic anion? Well, let's start with formulas to names. So we start the same way. So I'm going to underline my cations in blue. And I'm going to underline my polyatomic anions in green. And what we said last time was with our type 1 cations, it's just the name of the element. So this is going to be calcium. Calcium. And you should have memorized by now that CO3 is carbonate. So you just have to use the name of the polyatomic ion as the name of your anion. Here I have, so how did I know this was an ionic? First of all, let's go back and review this too. How do I know this is an ionic compound and not a covalent or molecular? Because I have metals. Calcium, potassium, calcium, magnesium, these are all metals. And these are main groups, they only ever form one charge, so they're type 1. So that's why this isn't calcium carbon trioxide. These you don't use the covalent prefixes. There's no prefixes with ionic compounds. No prefixes. So this is going to be potassium. And if you don't remember from memory what SO4 is, you can look it up on your chart. That's going to be sulfate. All right, do the next two as practice problems. Pause the video here if you want. Okay, welcome back. How'd you do? Did you write down calcium nitrate and magnesium perchlorate? You'll notice too that there's parentheses around this. So calcium nitrate, it's calcium, and then we have parentheses, and there's a 2 outside. What this means is that if I looked at this molecule, I would see a calcium attached to 2 nitrates. So if you didn't have the parenthesis here, it would be written as CaNO32. Now you're saying you have a calcium surrounded by 1 nitrogen and 32 oxygen. So it's a little bit like what you do in algebra if you've got 3x and plus 2, and you want to multiply that whole term by 3. If you don't put parentheses around your 3x plus 2, you would take 2 times 3, and you would have 3x plus 6. So the parentheses mean you have to take everything inside the parentheses and multiply it. So it's the same thing we have going on here. Okay, so that is formula to name. How about name to formula? Let's start off with magnesium chlorate. Magnesium chlorate. Well, we said the first thing you want to do in the last video was you need to write your ions with their charges. So I'm going to write the magnesium ion is Mg plus 2. Chlorate is a polyatomic, and it is ClO3 minus 1. If I put this together, if I write this formula as MgClO3, remember our net charge has to be 0. Our net charge must equal 0. If I do a 1-to-1, I've got a plus 2 and a minus 1. That will not be 0. So what I'm going to have to do is I'm going to have to do 2 of these. So my formula would be Mg, and I have to do parentheses, ClO3, 2. Again, if I write it without parentheses, I'd be saying I'd have a magnesium ion, a chloride ion, and 32 oxygen. So you have to have parentheses. Also notice there are no charges here. You can't put charges in your final compound formula. All right, next one is sodium hydroxide. Sodium, when you look at your chart, or if you just look at your periodic table, you should know those always form +1s. Hydroxide is OH with a -1. So this guy's super simple. I've got a +1, I've got a -1. Okay, pause the video and work on these next 2 problems as practice problems. All right, welcome back. Let's see how you did. Do you have aluminum as +3 and sulfate as SO4 -2? I hope so. And to get these to equal out, you're going to have to look for that least common multiple, or least common, multiple, I think. And you're going to find out that you're going to need 2 of these, and you're going to need 3 of these. +6, -6. And so my formula here is going to be Al2, and I have multiple polyatomics, so I have to use parentheses, SO4, 3. All right, finally, calcium nitrate. Calcium's +2, nitrate is -1. I'm going to need 2 of these to balance out my +2 here. My formula is going to be CaNO3, 2. Right, so that is type 1 cations with polyatomic anions making quaternary compounds. Our takeaways, remember there's no prefixes when we write ionic compounds. And in order to know these polyatomics, you're going to memorize them. So if I look at this, I've got calcium, and I need to know the name of that's carbonate. Potassium, the name of that's sulfate. When I write the, forgot my E. When I write the formulas, my net charge still has to be 0. It's an ionic compound. So I have to write my ions. Magnesium's +2, chlorate's chlorate's -1, so I have to have 2 of these to balance out one of those. And that is our rules for this group. Thanks for watching.